So let's solve the third problem at A. Let's use matrix method to solve the initial value problem. What we have to do is to transform this second order differential equation into a system of first order differential equations and then form the resulting system by matrix method. So first step, we write this differential equation in such a way that we make the highest derivative the subject. Thus, I mean, we write d squared y dt squared equals to minus 6y plus 5 dy dt. And for convenience, I can write this one as y double prime equals to negative 6y plus 5y prime. Let me call this one star. Then I let y to be y1. So which means that y prime will be y1 prime and y double prime will be y1 double prime. So this implies that this star equation can be written as y1 double prime is equals to minus 6y1 plus 5y1 prime. So this is still the star equation. Now I introduce a new variable called y2, and I say let y1 prime be given by y2. So once I introduce the next new variable, I call this equation 1. With this equation 1, I say differentiate equation 1, i.e., I mean equation 1 is y1 prime equals to y2. So I'm differentiating. So this is the same thing as saying y1 double prime equals to now y2 prime. So which means that where there's y1 double prime in star equation, you replace by the new variable y2 prime. So which means that that equation will be y2 prime is equals to negative 6y1 plus 5, but instead of writing y1 prime, because y1 prime from equation 1 is y2, I write 5y2. So this is my second equation. Now we write this equation 1 and equation 2 in such a way that each of them has variables y1 and y2. So equation 1, I write y1 prime equals to 0y1 plus y2. So this is still the equation 1. And in equation 2, I write y2 prime is equals to minus 6y1 plus 5y2. This is still the same equation 2. The reason why I'm writing this term is to ensure that every equation has y1 and y2. Now, with the given initial conditions, then we'll have converting this one into matrix form will be y1 prime, y2 prime is the same as 0, 1, minus 6, 5, and then y1, y2. So this is what we have. Now, because we were told that y at 0 is given by 1 and y prime at 0 is given by 2, then we can write these initial conditions also as y1 and then y1 prime actually at 0 is given by the vector 1, 2, since y and y1 are the same things. So with this matrix equation, we have the equation. So call this one capital Y dot equals to this one, call it A, and then call this matrix Y. So this is what we have. So the problem now reduces to solving Y dot equals to A, Y. So then next find the eigenvalues of matrix A. Eigenvalues of matrix A will be given by determinant of A minus lambda I equals to 0, which will be determinant of 0 minus lambda minus 6, 1, 5 minus lambda is equals to 0. So which will be negative lambda into 5 minus lambda plus 6 equals to 0. You get lambda squared minus 5 lambda plus 6 equals to 0, which is the same as lambda squared minus 2 lambda minus 3 lambda plus 6 equals to 0. So this will be lambda into lambda minus 2 minus 3 into lambda minus 2 equals to 0. So lambda minus 2 times lambda minus 3 equals to 0. So you say lambda 1 is 2 and lambda 2 is given by 3. So once you get eigenvalues, you get eigenvectors. So eigenvectors, let's start with lambda 1 equals to 2. We'll have to solve the equation AU1 equals to lambda 1 U1. So 0 minus 6, 1, 5 times U1, U2 gives us 2 U1, U2, which will give us U2 equals to 2U1, call this one equation 1, and minus 6 U1 plus 5 U2 equals to 2 U2, call this one equation 2. Now from equation 1, actually 1 and 2 are the same. We let U1 to be T, where T non-zero real number. So this will imply from equation 1. So the U2 will be given by U1, U2, which will be T and then 2T, which will be 1, 2, T, and letting T to be 1, then U2 vector will be 1, 2. So this is the U2 vector. Now, once you have the U2 vector, you need now to calculate the first solution, Y1. So that means Y1, which is given by U e raised power lambda 1. So U1 e raised power lambda 1 T is 1, 2 e raised power 2 T. So call this one, say 1 dot. Then for lambda 2, we have 0, 1, minus 6, 5, multiplied by u1, u2 is equals to 3, u1, u2. This means we'll have u2 equals to 3 u1 minus 6 u1 plus 5 u2 is equals to 3 u2. So equation 1, equation 2. So putting let t to be u1, where t is a non-zero real number, then this will imply that u2 will be 3t. So the u2 vector will be given by t 3t, which will be 1 3 times t. Then letting t to be 1, then u3 will be the vector 1 3. So that implies that y2 of t is u2 e raised power lambda 2t, which is 1 3 e raised power 3t. So we can call this one 1 double dot 1 raised power 2 dots, but you cannot call it any given number that you like. So by superposition principle, y of t is given by c1 y1 of t plus c2 y2 of t is a general solution. So which will be given by y of t is c1 1 2 e raised power 2t plus c2 1 3 e raised power 3t. So i.e. this one is a general solution. Y dot equals to a y, but that's not what we have been asked. So we need to use the initial conditions to find the values of C1 and C2. So remember, y of t can as well be written as C1 e raised power 2t plus C2 e raised power 3t, and then 2C1 e raised power 2t plus 3C2 e raised power 3t. Now, from the initial conditions, we know that y at 0 should give us 1, 2. This is actually from what is given as the initial conditions. So when you put t for 0, we'll have C1 plus C2, 2C1 plus 3C2 should give us this vector 1, 2, from which it implies that C1 plus C2 is 1, call it equation 1, 2C1 plus 3C2 is equals to 2, call it 2. Now from equation 1, C1 is 1 minus C2. So replacing this one in equation 2, so we'll have 2 into 1 minus C2 plus 3C2 equals to 2. So 2 minus 2C2 plus 3C2 equals to 2. So C2 is 0. Now C1 will be 1. So therefore, the particular solution is, so everywhere there's C2 in this solution, we put 0. So we don't have this part. So just have y of t is given by e raised power 2t and then 2e raised power 2t. But remember, the first row represents the y1. This represents the y1, while this one represents the y1 prime, which is the same as the value of y, which is the same as the value of y prime at t. So the required solution for the problem is this first row in the particular solution. So hence, the solution to the problem to the given initial value problem is y of t is given by e raised power 2t. So that is what we were supposed to arrive at the end. Thank you.